Hello friends, today we'll start with next case of problem. Take down the problem. An I section is connected by welds as shown. This is an I section which is connected to another column. Determine the load which can be carried safely. I need to determine load P. The size of the weld for web is 5 mm and flange is 10 mm. Assume field welds. So note down the things here. Size of the weld for flange and for web, they are different. Now let us mark those loads welds. Let this be flange weld, this is the web. Let us mark the dimensions. Let this be 400 mm, this weld 250 mm. Size of the weld for flange, it is 10 mm and for web it is 5 mm. So different welds are given. Let me draw another section which will make the things clear for you. Say this is the column. This is the I section. Now I am going to provide the weld. This is the flange weld, 10 mm thick, size is 10 mm. This is the web weld, size of the web weld is 5 mm. So this dimension is given as 165. Now let us start with the solution. First I need to determine area of the weld. In earlier case, when thickness was same, directly I calculate L into T. Now here different lengths are there, different thicknesses are there. So I need to determine total area of weld. Flange weld thickness is equal to 0.7 into 10, that is 7 mm. 0.7 into 10 is thickness of this flange weld. Similarly, web weld thickness is equal to 0.7 into size of this web weld, 0.7 into 5, I get 3.5 mm. Next, area of weld. So area of weld is equal to 165 into throat thickness, that is 7 mm, 2 1 and 2 twice, plus 250. So this dimension is 250 into throat thickness 3.5, 2 times. So I'll write that equation here. 165 into 7, 2 times, plus 250 into 3.5, 2 times. So area of weld I get 4060 mm square. Now let me draw a detailed diagram of the weld portions, only the weld. So this is the flange weld. Web weld. So this shows only the welded portions, only the weld I am going to show. Let me mark the CG of these points separately. This is the CG point, CG and another CG. Let me mark the X and Y axis. Let this be X, Y, y. This dimension is 165. This hole is 400, so 200, 200. This weld dimension is 250. Thickness of this flange is 7. Thickness of this web weld is 3.5. Let this be y max. Y max. Now I need to calculate Ixx, moment of inertia about Ixx, x-axis. Let me start with these two sections. BD cube by 12. B is 165, D is this throat thickness T. So 165 into T cube divided by 12 plus area. So area of this weld is 165 into T into distance square, distance of CG of this element from XX axis here till here. This distance is 200 square. I am having two areas like this, so multiply by 2, 1 and 2. Now let me write Ixx for this portion, for this vertical web welds, plus BD cube by 12. So B is T into D is 250 cube by 12 plus area 250T, CG distance. So this YY axis almost coincides this. This distance is negligible, so I am going to take that, consider that as 0 twice, because two areas like this. So TQ I am going to ignore, this term is 0. So I get the values Ixx is equal to 2 times 165 into 7, this web weld, into 200 square, plus 2 times T. T is 3.5. This is for web, this is for flange. 3.5 into 250 cube divided by 12. So Ixx value works out to be 101.5 into 10 raised to 6 mm raised to 4. Now let us calculate moment M. Is P into E. Load P into E. Load P, let that value be in kilonewtons, so I am going to convert that into newtons. P into 10 raised to 3 load. Eccentricity E is 250. So I get the value 250 into 10 raised to 3 P Newton EMM. Similarly, let me identify value of Y max. Farthest point of weld from XX axis. Let this is the farthest point of the weld. Its maximum distance from XX axis is 200. So Y max is 200 mm. Okay, 1 second. So here we start. Direct stress is equal to F1 is equal to load divided by weld area. Load is P into 10 raised to 3 in terms of newtons. Weld area is 4060. So F1 is equal to, this works out to be 0.2463 P newtons per mm square. This is stress. Similarly, stress due to moment F2 is equal to m divided by Ixx into y max. So I can write that equation as 250 into 10 raised to 3 p divided by 101.5 into 10 raised to 6, that is I. Y max is 200. So solving this equation, I get F2 is equal to 0.4925 p newtons per mm square. Now I am going to equate this to the resultant. So resultant R is equal to F1 square plus F2 square, and this should be less than or equal to characteristic weld strength. So let me substitute the values. 0.2463 p, note here 0.2463 p bracket square plus 0.4925 p bracket square. This should be less than or equal to Fu by root 3 into gamma mw. So that I am going to substitute the values. 410 divided by root 3 into gamma mw. For field welds, gamma mw is 1.5. If we are going for shop welding, partial safety factor is 1.25. For field welds, gamma mw is 1.5. So I will get that equation as 0.2463 p bracket square plus 0.4925 p bracket square is equal to 157.8 bracket square, which is equal to 24903.7. So let me square it. Let me put it here like this. So I am going to square on both the sides. 0.2463 p bracket square plus 0.4925 p bracket square is equal to 24903.7, or same I can write 0.30 p square is equal to 24903, or p is equal to 286.57 kilonewtons. This is the load. Now I need to determine working load. Working load or safe load is equal to P by 1.5. 286.5 divided by 1.5. So P I am getting 191 kilonewtons. So this completes the problem. Thank you.